Welcome to the Edu-Robo tutorial, day 4 session. Today's session is on software and hardware. It's the first session on the software and hardware, specifically related to the board which we have designed for this program. As you know, we have designed this course for 3 levels. Level 1, we are not making any assumptions. Level 2, with a little bit of programming skills and knowing about the hardware. Level 3 consists of some uh, Internet of Things or cloud platforms, mobile apps, and interface to a Edu-Robo, slightly uh, application level. Okay, so since you have registered this course, we have provided all of you this hardware, right? This kit. This is what we called as a do-it-yourself kit. So what do you have in this kit is one, our own design board. What you can see is this board consists of, right, there is a CPU, microcontroller, and then some peripherals are also populated, right, and then some connectors and some sensors. And it also has a provision for connecting the motors, dummy wheel here and 2 motors here. And through USB you can power up, or through battery you can connect it here, and this is the on off switch. Okay, let's see how to make use of this board. I mean, the complete journey is all about how to make use of it. On the bottom side also you can see some sensors are there, what we call as a line follower sensors, infrared sensors. Okay, we will see. And then the kit also consists of the there's a cable, USB cable, to power it up and also to program the kit. And there's a liquid crystal display, right, LCD, which has, as you can see, it can display 2 lines and 16 characters, what is called 16 by 2 LCD. Then you have provided with a pouch, consists of some ICs, motor driver and sensor driver ICs, dummy wheel and the clamps and a few spacers and few screws. This is to assemble the robot. There is no hurry right now. Initially we will be programming the mathematics, right, that is higher secondary level mathematics. We will be programming on the board, right. We will program this board some mathematical expressions and we will see the results. And also it has 2 DC motors. These 2 DC motors, eventually you are supposed to mount it, fit it along with this dummy wheel. There is a dummy wheel here, third wheel, and then 2 tires. Okay, so this is called our basic kit. Basic kit means without having that Wi-Fi, Bluetooth or some advanced sensors, the basic necessary kit with the peripherals, so that we can practice some programming skills, also small applications like robotic applications. All right, so that's about the kit. Now this session is about to knowing about the first is about the software. We all know any living being without life, it's a dead system. So similarly, a CPU, central processing unit, or we also in this course we call it a microcontroller. A microcontroller without program is a dead system. Though you give the power, but it doesn't execute any of these things. So as discussed, as you can see on the board, there is a microcontroller CPU, and some peripherals are populated, some sensors, and of course there is an on-off switch. So as I was telling, hardware and software, both of them are equally important. Without hardware, there is no software. Without software, there is no hardware. Like living beings, without life, it's a dead system. It's just a skeleton. It's like a human without life. So similarly, a CPU without instruction, without program, it's a dead system. So you can use any of the compilers, right? There are several compilers in the market for programming the CPUs. Particularly for desktop systems, we have C, C++, Java, VB, .NET, and so on. But since this entire program, this course is all about other than computers, that is, you can say robots or standalone systems or application specific systems. For programming these CPUs, we don't use the compilers which are used in computers. For the obvious reasons, the CPU is Intel, whatever today we are using, Intel architecture, i3, i5, i7. They are not the CPUs what we use on these boards. They are altogether different. So in short, they are called microcontrollers. So microcontrollers compilers are different. Keel is one of the compiler. CodeVision AVR is another popular compiler. Like that, there are some compilers are there, but those compilers are hardcore compilers. They require little bit of architectural details, peripherals details. Then only we can write the programs. Since this course we are planning from schools itself, from 10th, 7th, any at least let's say 7th onwards, programming skills, we thought of using popular compilers where you don't need to go for much details of hardware initialization. Several things are already done in the compiler itself. They are available as a functions. Maybe few commands, very handful of commands you have to use it. Another advantage of going by this compiler, Arduino compiler, is it is same as C compiler. Syntax point of view, it is same. You don't need to learn any new compiler once you know the C language. So whenever we create a project, that project called here, we always call a sketch. So by default, Arduino compiler, when you create any project, that name it gives as a sketch. You can rename it, of course. But a project means it consists of two functions. Whenever you create a project, that is sketch, it consists of void setup and void loop. So that's all. Any program, any number of programs you create, the structure in Arduino is called void setup and void loop. Void setup function, we use it for initialization purpose. If you have any variables initially you want to set, or if you have any hardware initially if you want to initialize, then those things we write it in the setup. So whatever you write in the setup is executed only once, and it executes first. These are the two things. First it will execute first, then it execute only once. Then it go to the void loop. So whatever you write in void loop is executed again and again. It doesn't mean that you have to put both entire code in the either setup or loop. You can also create your own functions and call them. But the functionality of setup is run first, and once the functionality of the loop is execute again and again infinite number of times. So these are the two very specific functions of the Arduino project when you create. So the development cycle in Arduino compiler is in 4 stages. Since this entire program, whatever you write it on the Arduino compiler by using editor, you are supposed to compile it. Editor is just to type the program and save it, that's all. Editor doesn't understand what you have written, right? But then compiler will try to convert your program into its machine language, binary language, zeros and ones, and that to absolute coding, not a dynamically relocatable coding. As I spoke in my earlier videos, dynamically relocatable happens in computer because computer, there is a hard disk and there is a memory, and the memory has to managed, memory space has to be managed with the hard disk programs. So memory management takes place, so virtuality takes place. So that's why every program, every application program in the computer is relocatable programs. Their extensions are called .com, .exe. However, in our case, in microcontrollers, other than computers, the extension is either .hexa, Hex, or .bin, bin files. But in any case, they are binary only. Only difference is absolute addressing. Absolute addressing means their physical locations, their physical memory locations are fixed. Which program should reside where the data should be stored, where the application program should be stored, where the firmware should be stored, where the interrupt vector table, everything is absolute addressing, no relocatable. Alright, so once you compile the program, then actually in computer what happens is after compiling, you run the program because the program is already there in your physical memory space, you execute it. In our case, you cannot execute in the computer because the CPU is not there in computer. The CPU is, that's what I have shown you, is there on our board. So you have to load the program from the computer and on the board. Okay, so that's why we say upload. Upload means transfer the program from the computer to the board. Like in the previous lecture, I have shown you what in the real-time emulation. Emulation means now in real time, in natural time, I am transferring the program from computer to my board. Since my board, that is a CPU, has a flash memory, which is rewritable but non-volatile. Non-volatile means even if you switch it off, the program will be still there. In computer, we are loading the program in the RAM, which is volatile. Means if the power goes, your program is gone, your data is gone. But in microcontroller, we are writing into the flash memory. Even the data also we are writing in the flash memory. So that's why, even if we switch it off, the program will be still there. So that's the meaning of upload. Upload means transfer the program from the computer to the microcontroller's flash memory. Then run. Run means as soon as you start executing, right? If you say execute the program, or on your board you also have a reset button. The other way is either switch it off and switch it on again. So that is as good as a run. It will start executing the program from the first location. So what in the first location? In our case, first location means whatever you write in the void setup, right? That will be executed first. So from there it will start executing the program. So these are the 4 stages of Arduino compiler. Edit means type the program, compile, convert into machine language, upload means transfer the program from the PC to our board through USB port, and then run. Run means execute the program on the board, not in the computer, because we are not using any simulator here. There are some simulators, online simulators also available like Tinkercad and so on, but we wish to see actually activity based learning. That means physically we want to do the things, see the things. Then we will have confidence that in real time, in real life, how things works. Okay, so the tutorial for this week for you is you are supposed to install the Arduino compiler by downloading and installing. Then you also verify whether your board, when you connect it to the computer, it is being recognized or not. So you need to check it up, whether the your USB, when you connect it, it should recognize. I will demonstrate to you. Then in Arduino compiler, you are supposed to select the port, because the port is something which is allocated dynamically. It's not static, it is not fixed. It is computer to computer, USB to USB, the number will change. So how to select the port number in your compiler? Then you are also supposed to select the board in the compiler, because Arduino supports several boards, right? Wide variety of CPU boards, right? We have designed our own board. Like that, several companies are designing their own boards. So you are supposed to select the port, you are supposed to select the board. Then I will show you, write one simple example program, which is already there in the Arduino compiler. Then load that program, compile it and transfer, upload the program. Yes, if a program is working fine, that means at least you know minimum things like compiler installation, then selection of the your device, that is called port, communication port, then selection of the platform itself, that is a board, then load at least one application example, compile it and transfer it and see the results. So these are the minimum things which we expect this week tutorial. So if you want to download the Arduino compiler, type Arduino download, then you will find www.arduino.cc, right? This is their website. What you can notice is the latest configuration, Arduino IDE 1.8.19 at this point of time. Either you can download it, this compiler, or if you already, I will share you my link. From there also you can download it and install it. While installing, just keep on selecting next till the end. After installing, it may ask you, do you want to update? Say no. I mean, don't do that generally. Updations are not required. Okay, so this is the easiest way to download the compiler. As I was telling, the compiler is a freeware. You don't need to buy the compiler. Similarly, there are some other variants are available for Arduino compiler. Like if you are using instead of Windows, right? If you are using Linux as a operating system for your computer, then you can also use Linux variant, right? Or even Mac also, they have a new version for the Arduino compiler. So compiler is free. So just download it and install it. After installation, as you can see, it may ask you, do you want to update your compiler? You say no, no need to update the compiler every time. You can see the Arduino compiler editor where you can type your programs. Whenever you want to use this compiler, few things you should remember. I was telling you, that is port selection, board selection is mandatory. So how to do this, right? Uh, let's not worry about other options, like as you can see, preferences, page setup, all these things are open the examples, existing examples that we will see eventually. Similarly, in the sketch also you have add a file, include a library. So those things also we will see later on. In tools, at this point of time, I am telling you only two things. One is the board selection. As you can see in the board selection, you have wide variety of boards. Okay, so as a programmer, you are free to choose any of these boards. when you buy it, or if you make it a equivalent board of these things. Or if any board is not existing, then go to board manager. There, from here, from the board manager, you can install the new boards. So at this point of time, let's not worry about the other types of boards. We are selecting Arduino Uno. So this entire three levels, if you are using the board which we have provided, always keep Arduino Uno as a board. So that is one thing in the tools. Second thing is the ports. The ports are communication ports for transferring the serial, or you can say serial ports. These are the ports which are used by the computer to transfer the program from the computer to your target board. How do you know the numbers? It may show you multiple numbers, it may show you single number, or every day it may change the number. So how do you know which port to be selected? So I will show you. Before that, we are supposed to do something else. So let me show you the board, where to connect. Let me tell you how to give the power to the board. Then we will see about the port number. So as you can see the board, there is a USB connector, mini USB. So the cable which we have provided, one end you connected to the computer's USB port, the other end you connected to the board itself. But then even then it won't get the power because we have provided a on-off switch. Right? There is a push to on switch. Maybe in future when you connect some battery and all, we thought at least there should be on-off switch on the board, so that as and when you are not using, you should be able to switch it off rather than removing the connector. So now I've pressed the power on button. Now through this USB cable, this entire board is getting the power. Right? There are some couple of LEDs here, sensors, sensor indicators, and then this LED is called power on off. So since now the power on off, as you can see, I will switch it off now. The power is gone. Again, power is there. Okay. So what I want to tell you is that near the USB, there is a one IC called USB to UART converter. This actually, what we have connected is USB, but this fellow will convert into serial port, serial communication, right? Maybe in 1990s, maybe till 2000, computers were not having USB. The communication was called serial port, or UART, Universal Asynchronous Receiver Transmitter. So those days, they were communicating by selecting some baud rate, number of bits per second. But today we do not have a choice. We use USB, which is a synchronous communication. But earlier we were using asynchronous communication. Asynchronous communication means the clock of this, the clock of that are not same. They are independently working. Okay, anyhow, so this IC, which is a converter, which converts this USB into COM, and now that port is connected to our microcontroller. But what I was telling you is that the number, port number, is not same. Whenever you connect it, your operating system, right, your Microsoft operating system or Linux operating system recognizes this IC because you have connected to USB, and of course it also has a device driver in order to detect that. Then it will dynamically assign the number. So what you need to do that, since anyhow we have connected the board, you can go to your search, right? There you type device manager, right? If you select the device manager, you can see, right, if ports, right, you can, in the device manager you can see as a ports. If you expand the ports, what it shows is, as you can see, the third one, USB serial CH340, right? So CH340 is this IC number. So this fellow is converting your computer's USB to serial port of your microcontroller. So it's called converter, protocol converter, one form to other form. Like now we have a language translator. This fellow is translating USB to serial port. But then you can see in the bracket it has given some number, COM6. This is what we need to know, that the operating system has recognized this board and has assigned some number, or you can say it's address. So every time computer is transferring the program to this address called COM6, it's a channel, right? So that's why we open the device manager, just to confirm whether this computer has recognized this board or not. Please remember, it's an important step. Every time, just make sure uh, the computer has recognized this board. So that means connect the USB, connect to your microcontroller board, switch on the power, and then verify, go to device manager and verify it has assigned any number or not. If the number is not assigned, that means there are multiple reasons. A, your operating system, in the operating system, the required software, device driver software is not either installed or it's not there. We generally don't install is because by default it's already recognizes as a part of the device manager. If it not, then externally we have to install, but generally latest operating systems are inbuilt. That is one thing. So there is a possibility of operating system is not recognizing. Second possibility why it is not working is because your USB is not properly connected or there's a cable problem. The second reason. Third is your board, on the board, the power is not given or the USB converter is not working. So these are the four reasons there is a possibility of why this number is not assigned or why this device is not detected. It is must for the entire our journey of detecting this board is because after writing the programs, we are transferring our programs from the PC to the board. Okay, so in the Arduino compiler, what you can see is go to tools. Now if you see the port, right? Now in the port, now you see there are other ports also there, 1, 3. But we are not interested in 1, 3 is because the device manager has assigned as a 6. This 1 and 3 are something else which are not part of our device driver. They are inbuilt computer, or majority of the computers even there doesn't have inbuilt serial ports, right? There won't be any ports, so in that there won't be any confusion also. In my PC there are 2 more ports, so that's why it is giving 1 and 3. But actually we are interested in this CH340, which is COM6. Now I am saying my port is COM6, I have selected. Second, my board is Arduino Uno. So remember, these are the two things which are must. Okay, so let's not worry about what I have written, but whatever is there, right? Or you can go to file, then you can go to examples, and there you can also see in basics, right? You have blink. Blink is one of the example, you can load it. Or you can simply say go to new, right? It will simply create a blank space or template. Just simply say new. You can see the name of this program it has created as a sketch. That's what I am saying, that project here is called a sketch. But you can also say file save, right? Then it will give you a new name, whatever. In Arduino, right, in your C directory in Arduino, it will create this file name. But there are already some, right, in this folder, there may be some other libraries are installed, files are there. So let's give some name called, let's say, for example, test. I had given test. Say save. Now see, my name of the project is called test. So this is what I was trying to tell you, that it will create two loops called void setup and void loop. So whatever you write in void setup will execute only once, but first. Then whatever you write in void loop is executed repeatedly again and again in infinite number of times. You can also have some other functions and call it from either setup or loop. It's your choice. But I was telling that since you have selected the board as Arduino Uno, port as a COM6, you can see in the bottom of your screen, right side, Arduino Uno and COM6 are displayed. So you should always verify this. What your device manager is showing, the port number, right, and the board which you have designed or which you have connected is Arduino Uno. Board should be selected here. Once that is done, then this is the what I was telling you, two steps. This right tick is called compilation and the right arrow is for upload the program. So first let me compile by verifying. So once I select it, whatever is the program here is there, you can see from the bottom of the screen the compilation is taking place. Now it says done compilation, means there is no syntax errors. Right? Syntax errors means typing errors. Instead of, right, these things, if I type something else, or the functions which are not existing, then those are called typing mistakes, where a compiler doesn't recognize them. But if they are the inbuilt functions, right, or inbuilt those keywords, then the equivalent of these things will be replaced by the machine language, binary language. It will convert it. All right, compilation is done. Now I want to load the program, upload. If you upload, then compilation also will take place. Both it will do. Right, done uploading. That means you can see AVR dude done. This is what exactly you should get every time. Right, if the board is okay, if the port is recognized, and if device is working, then whatever you say after compilation, when you say upload, then the program should transfer from the PC to the target board. Let me show you some results by some other program. In this program, what I am trying to do is, in the void setup, I will explain you later. Just quickly, what I have written is serial.begin 9600. So this is what I am trying to do is, I want to transfer some data from my board to some other device with a speed of 9600 bits per second. Right, again serial port only, serial. Right, just now I was telling you serial, this is also serial. By using the same USB cable, right, I want to transfer this entire data from the board to some other device. Then, so this is executed only once because I have written in the void setup. After that, in the void loop, what I said is that serial dot print ln line, print ln in the bracket t. So what it does is print, as you know, print in normal C also. Print means display the text on the computer monitor. However, in our case, since there is no monitor, there is no computer type monitor, so print means actually serial print. Please remember, serial print. So that means it will transfer serially your text. What it will transfer? Whatever you have written in this bracket, right? So what you have written in the bracket is a T. What is T? You have defined in the beginning. Before that, just quickly demonstrate, let me demonstrate. So next week onwards, we will practice more on what are the various types of data types, what are the functions, operators, arrays, and so on, conditional statements, and so on. So in this program, I have defined some number, floating point number, and that number I want to transfer from my board to some other device. In this case, other device means today I am using computer as the other device. But in future, maybe in level 3, you can also use your Wi-Fi as the other device. It will transfer through your Wi-Fi, or mobile also you can use as the other device. Cloud you can use as the other device. That we will see. I mean, there are advanced parts. So today I am saying print means it will transfer the data from the board to the computer. But after that I am saying T plus plus. That means whatever is the T it has transferred, next time that number is added by T plus plus, means increment by 1. But then since this loop is an infinite loop, this will be keep on incrementing that number by 1 and it is printing serially. Okay, fine. So let's compile. Either you can only say verify or verify and upload. So I'm doing both now. If I press this right arrow key, it's not only compiling but it's also uploading. Okay, now it has program is loaded. The moment program is loaded, it will start executing. But then it is printing. Where it is printing? Through serial port. The serial port is connected to our USB port. That means the data is coming through USB port. USB we have connected to the computer. That means the data who is receiving? Computer is receiving. Alright, so where the computer is receiving? Go to tools. There is a the option called serial monitor and serial plotter. Serial monitor means whatever is the computer's serial port. Computer serial port means which port? We have selected COM6. So whatever is coming on COM6, it will monitor it. Monitor means it will display it on the computer screen by text form. But instead of that, if you say serial plotter, then whatever is the data coming through COM6, right? It will receive it and it will display it graphically by plotting. It's a graph. The numbers, like no, in your graph also, what you do between one sample to the other sample, you join them by a line in order to looks like a continuous type of a plot or a line or signal. But here also this software is joining the one sample to the other sample by a line. Let's see serial monitor. When you say serial monitor, you can see of course first please remember there is here the unit is called baud rate. You should always select the same baud rate whatever you have mentioned in the program. In the program we said serial speed. Speed means number of bits per second is 9600 bits per second. So computer speed also you should select same. Instead of 9600, if you select any other random, any other baud rate, you will see the display will be a garbage, right? Because there is a speed mismatch. Computer speed and microcontroller speed is not matching, so the data will become a garbage. That's why I said it's called asynchronous communication, because computer speed is different, your microcontroller speed is different, so transmitter speed is different, receiver speed is different, then there is a mismatch in the sampling data. But if you want the data sampling should be correct, then both the speeds should be same. Now you can see again it is started executing. Whenever you select the baud rate, it will start from the beginning. Program will start beginning from the beginning. Right? See, the number is always incrementing by 1. Okay, so this is one way of testing whether your program is working or not. This serial program, please remember only two statements just now explained. Serial begin means with what speed you want to transfer the data on the computer. Second is serial print line means whatever is the data is mentioned in the brackets will be printed on the computer monitor. So these two things we are extensively using at least couple of weeks to verify all our mathematical functions or to verify all embedded C programming skills, right? You will be extensively using at least these two functions. And keep it in mind, this speed should be same. The baud rate speed of your microcontroller, baud rate speed of your computer should be same. So this is just to display in a numerical form. But you can also display this number in a graphical form by going serial plotter. If you go to serial plotter, now you can see it has started from 0 and it is every time incrementing by 1, as you can see, and it is, but then between one sample to other sample it is joining them by line. So as if you feel it's a continuous waveform, But no, actually it's a discontinuous waveform. It is a discrete, means samples, but those samples it are joined by line. So you feel as if it is a continuous type of waveform or a line. But bird rate should be same. Otherwise, if you select a wrong bird rate, then the results won't be correct, right? It won't display correctly, or it may be garbage or whatever. So now I selected 9600. Now see it started again from 0, but then it will keep on incrementing by 1 and so on. All right, so this is what is expected, as I promised, that uh, Arduino download, how to download the Arduino, how to install it, as I already explained. How do you know whether board is recognized or not? Go to device manager and check whether that CH340 and in the bracket some port number is given or not. And then go to Arduino compiler, select the same port number, right, in the tools, and also go to tools, select the board selection as a Arduino Uno. Then in go to examples, any example or create a new example, and then just compile and download. All these things are happening, that means you have successfully completed Arduino installation and selection of the board, writing the program, compiling the program, downloading the program. That's all.